in a Cartesian plane, which is why you have to learn about it in college algebra. But this is Miss Smith here, bringing you a quick lesson about the Cartesian plane. By the end of this video, you should be able to plot points in the Cartesian plane, calculate the distance between the 2 points, and the midpoint of the 2 points. So when we're looking at a Cartesian plane, we use it for GPS, you use it for video games. Mario used to be able to just jump up and down, move left and right. Now, old boy can drive a car and go in all sorts of directions. That's because of the application of the Cartesian plane to video games. So I'm sitting here in a chair and I can change my Y value by adjusting the height on the chair. I can adjust my X by moving left and right. I can adjust my Y forward and back, or not Y, Z forward and backward, but you are just dealing with the two-dimensional Cartesian plane right now of X and Y. Never mind. So when we're looking at the Cartesian plane, you have your X-axis, which is your horizontal plane. You have your Y-axis, which is your vertical plane, or your vertical axis. And you have coordinates for squares, called a quad, 4, because there are 4 quadrants that are formed by these two axes splitting the plane. So your origin is the middle man right here. It is your point from that is relative to everything else. So that being 0, everything can be 1 unit, 2 unit, infinite number of units away from said origin or 0. So when you're looking at your quadrants, your first quadrant, everything's positive, X and Y. We'll look at that in a moment. Quadrant number 2, your Y is positive, but your X's are negative. Quadrant number 3, your X's are negative and your Y's are negative. And then quadrant number 4, X is positive, but Y is negative. That's going to be important in a little bit. So ordered pairs, when you're graphing ordered pairs, and why do you have 2 ordered pairs? Why? Because for any one point, you need 2 pieces of information. You need to know its X coordinate and its Y coordinate. And so when you're plotting points, let's say our example points right here, we have 2 and 3. So we'll do 2 and 3, and that will be point A. And when I plot them, is right here, my 2 and 3. X is positive 2, Y is positive 3. Then I'm going to plot my next one, negative 4 and 5. Negative 4 and 5. And 5. And label it. Because X is negative, it moves it into quadrant number 2, which is over here, but my Y is positive. So it's still, that means that it's above the X axis, because right here, that's where Y is 0. And then anything above 0 will therefore be positive Y. That's my point B. Then I'm going to do my next one. I have negative 3 and negative 2. So which quadrant should negative 3 and negative 2 be in? For our drum roll, please. Quadrant number 3. Why? Because they are both negative. So you have the negative x-axis over here and the negative y, and that'll be labeled point C. And then you have the 4th point. The 4th point is a positive 1, negative 4. So x is positive, lets us know that it's going to be in which 2 quadrants could it be in? If you said 1 and 4, you are correct. And negative 4 lets us know that it is in quadrant number 4. Okay, and that'll be point D. All right. So when we're looking at the Cartesian plane, it's how we can orient things in space. So now let's apply this knowledge. If you remember the Pythagorean theorem, a squared plus b squared equals c squared, well, that's what the distance for. The Pythagorean theorem, except you're not solving for c squared, you're just solving for c. The only way you can get a c from c squared is to do a square root, which is what you do. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. And then all of that underneath a radical so that you can find c, which is the distance from point A to point B. All right, so for an example here, we have point A has coordinates of 1 and 2. Point B has coordinates of 4 and 6. If I plug them into the distance formula, x's go together, x2 minus x1 squared, y2 minus y1 squared, and I end up with 9 plus 16. And then from there, I have the square root of 25. It's a perfect square. Life is awesome. 5. Why? Because 25, what equals 25? 5 times 5. So we have a practice problem right here. Yay. Marcus is a fitness enthusiast who loves to track his runs using a GPS app on his phone. He starts his run at the gym, which his app shows as a coordinates of 2 and 1 on a map grid. He runs to the park, shown as coordinates -3 and 5 on the map, where he does some body weight exercises. All right. Finally, he finishes his run back at the gym. So Marcus runs from the gym to spot B and then back from spot B to the gym. Perfect. If each unit on the map grid represents 0.8 miles, calculate the total distance Marcus ran. Think about how we solve this problem first. Let's UPS it. Understand, plan, solve. So, what is it that we've been given? We've been given 2 points. Point A, 2 and 1. Point B, -3 and 5. And we've been given a unit of conversion, 0.8 miles. So, as I said, we're looking for the distance between the two. Understanding it, I'm looking for the distance. I'm going to use my distance formula. Planning it, I'm going to plug in those values. 2 and 1, -3 and 5. But I need to label them. x1, y1, x2, y2. Plug it in to the formula. Now, once I find that distance, will that be the distance he ran? If you said no, we're doing good. Why? Because he ran from point A to point B and then from point B back to point A. So we'll find what we find will be the number of units he ran from point A to point B and from point B to point A. Well, from point A to point B. Then we need to multiply it by 2 to find his total number of units he ran between those 2 points. Then we multiply it by 0.8 to convert it from units to miles. So let's get to it. Using, let's see right here. So we're going to plug in our numbers. We have 2 and 1. I label them x1, y1, x, and then x1, y1, x2, y2. And then I put in my conversion. 1 unit is equal to 0.8 miles. Then I have my distance formula. x2 minus x1 squared plus y2 minus y1 squared. Ooh, I put a y2 right there. Oh, it's okay. I'm human. We make mistakes. So here, we're going to plug in our numbers or our values. I take my x2 minus my x1 and my y2 minus my y1. And my line went crooked. Oh, right there. And then I simplify that. -3 minus 2 gives me a -5 squared. Oh, got a frog in my throat. Okay. And then 4 minus 1 gives me 4 squared. Add them together. I have 25 plus 16, square root of 41. That's not a perfect square, but it's all right. I know it's between 6 and 7, and also we live in a time of calculators. So I indeed just plugged it in. You have 6.41 units. Now, we know he traveled 6.41 units 2 times because he went from the gym to the place in the park, from the park back to the gym. So I multiply it by 2 and I get 12.82. And then I multiply that by 0.81 or 0.8 miles, setting it up as using dimensional analysis. So I had 12.82 units. And then I multiply by a conversion factor of 0.8 miles for every 1 unit. Of course, with dimensional analysis, you want to cancel out units. So units here, so it cancels out. When I do the math for this, my answer will be in miles, and I get 10.26 miles. All right. Now, if we were going to graph this, what it would look like. And let's look at these 2 points. We have 2 and 1. And then we have our next point of -3 and 5. So these 2 points right here, the distance between them would be a total of 6.41 units. And then from there, that is equivalent to there and back would be equivalent to 10.26 miles. Straight line. The shortest distance between 2 points is a straight line. So we found it. Next, last but not least, the midpoint. The midpoint is the middleman. I have two values or 2 points. I have a y value or y1, y2, x1, x2. And then you're basically finding the average of the two. So you add them together. So we have, for example, right here, says that find the midpoint between point A, 2 and 3, and B, 4 and 7. Apply the midpoint formula. Midpoint formula is right here. X1 plus x2 divided by 2. Why are we adding them and then dividing by 2? Because, we're finding the average. We're just looking at the distances, the values for your given x values for these points. Add them together, divided by 2, because we're adding 2 together. Find the average. And then we do the same thing here. Y1 plus y2 divided by 2. And so we have 2 and 4, 2 being your x1, 4 being your x2. Add them together, divided by 2, we get 3. And then we do the same here. We have our y1, y2, 3 and 7. 3 plus 7 equals 10, divided by 2, you get 5. So if we were to plot those points in decimals, we have -1 and 3, and then 3 and 7. And yes. All right, so we have our 2 points, and then our midpoint is 1 and 2. And is it right in the middle? Drum roll, please. It is! Yay! Cool. All right. So we found our middleman right there. So by the end of this video, you should be able to plot points on a Cartesian plane. Say Cartesian or Cartesian? I don't know. British American way. Yeah, you choose. You do you, boo. So Cartesian plane, we can plot points. We can determine the distance and the midpoint. Right? Peace out.